Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to talk about the topic Boyle's law of gas, and here we are going to see about what are the mathematical expression, and we'll also verify that how the Boyle's law is valid for a particular gas. So let us talk about it. So this is the statement of the Boyle's law for gas, and what is that? Let us see that also. So according to Boyle's law, it states that at constant temperature, the pressure of a given mass of a gas varies inversely with its volume. It says that if a gas has a particular mass, and that mass is kept to be constant, and even the temperature is kept to be constant, and whatever the pressure would be, it would be increase or decrease, it would be basically inversely proportional to the volume. So therefore the pressure and volume, they both are related to each other in an inversely proportional manner. So what is that? Let us talk in terms of mathematical expression. So that's what we have learned in Boyle's law, that for a gas, that is the pressure P is inversely proportional to the volume of the gas. But yes, there are several conditions also that what it has mentioned, that at constant temperature and at that is given mass of a gas, and if that gas has a particular mass, and if we know the molecular mass of that gas, so therefore we could say that the number of moles, that is N, is also known to us. So therefore N is also said to be constant. So if these two conditions are to be kept constant, and if we know that if the pressure will increase, then we know that the volume will decrease, because they are inversely proportional to each other according to Boyle's law. So this can be expressed as P is equals to K1 into 1 upon V. So this is what we have equated in this form, and moreover we could say that this equation can be written as, that is PV is equals to K1, where K1 is equals to proportionality constant, or we could say it as a constant itself. So this is the equation, this is the mathematical equation of the statement that we have made for the Boyle's law. And suppose this is the equation, that is P into V is equals to K1. So therefore the statement can also be written as that according to the Boyle's law, the product of the pressure and the volume is basically constant. So let me assume that if we have two conditions, suppose in that condition we have pressure of the gas as, suppose, named to be as P1, and which is basically inversely proportional to the volume of the gas at that condition as V1, and the temperature is said to be constant. So therefore we will maintain the temperature to be constant, and even it has the specific volume of or it has the specific amount of gas that we have taken in this consideration. So that's the reason that the number of moles of the gas will also be the same. So therefore N is equals to is also a constant value. So if this equation, if we have applied a Boyle's equation in this manner, where we have a pressure as P1 and the volume as V1 for that gas, so therefore this could be written as P1 is equals to K into 1 upon V1. So even that could be written as like this one, that is P1 V1 is equals to K, where K is known as proportionality constant. So suppose this equation is considered to be as equation 1. So this is the first condition where the pressure is P1 and the volume is V2. But what about, suppose if we have considered another condition where the pressure is not similar to that of the P1 and the volume is also not similar to that of V1. But yes, the constant temperature would be maintained as it is, and the number of moles of the gas will also be considered to be the same thing. Only this value would change. So how we could write that? That also we could write in terms of the Boyle's law, and in that case basically the pressure of the gas would be considered to be as P2, and even that would be inversely proportional to the volume, suppose V2, and at the similar temperature, that is at the constant temperature, and at the number of moles would be also be the constant for the gas. So this is the condition that we have made, and in this case we could also write this equation as P2 is equals to K into 1 upon V2. So therefore this could be also written as P2 is equals to V2 is equals to K. So let me consider this to be equation 2. So this is here also we have applied the Boyle's law, and in this case we have got a value as the product, that is P2 into V2 is found to be the proportionally constant K. But this is the K, that is the constant value that we have also got in equation 1. So that is the thing that we could equate both the equations. So we could get as equating equation 1 and 2, we get, since both the proportionally constant, or we could say they are same, so therefore we could say that P1 V1 is equals to P2 V2. So this is the condition that we have got, and this is the mathematical expression of Boyle's law. It states that at constant temperature and at a given mass of gas, the product of the pressure and the volume remains the constant. So this is how we have mentioned that the P1 V1 is equals to P2 V2, and the both will be the same, and if we will consider about the products. So this equation can be mathematically or can be verified also. So this is the mathematical equation that we have represented for the Boyle's law, but we can also verify by experimental conditions. So how? Let me explain that. So suppose this is an apparatus which consists of two basically calibrated burettes. So these two are basically calibrated glass burettes. That is what we have taken here. And in this case, the green part that I have made, in this case basically the gas would be occupied, and this calibrated glass burette will consist of basically mercury. So suppose the mercury is being filled over here in such a manner that both the levels are being same now, and this is the delivery tube which connects this burette to this burette. And suppose in this condition, suppose if the both will have same layer of that is the level of the mercury will remain the same, because in this case we have not extended the pressure, even we have not extended the volume of the gas, and the volume of the gas is kept to be constant. In this case, suppose the volume initially has, this burette initially ranges from 0 to basically 100 cm cube. So this is the range of the burette that you could see on the left hand side, and this burette consists of the mercury. And suppose this is the burette A and this is the burette B, and this is the mercury level that you could see over here. So this is nothing but the mercury that we have made to, and this mercury will go over here till this much, and both the layer would be same at normal condition. So but the gas or the pressure that has been applied through this side is basically 1 atmosphere. So suppose in this case we are talking about conditions. Suppose in this case we are talking about various conditions, that is condition number 1, 2 and 3. Suppose in first condition, if we have maintained the pressure to be as 1 atmosphere, and the 1 atmosphere will be because of, as we could see, the mercury level that has been filled inside, and it will have a particular height of, we could say, as 760 centimeter of Hg is been filled in the as we could see in this tube, that is B. So therefore if we compare this 760 mm if 76 centimeter of Hg, then according to this is also been used as a manometer. So therefore this whole apparatus can be used as a manometer, and in that we know that 760 mm Hg, or we could say it as 76 centimeter of Hg is equals to 1 atmosphere. That's the reason we have taken the pressure to be called as 1 atmosphere, and this is suppose the condition 1. If I am writing here, suppose if it is the first condition, and in this case what we could see is the gas that has been filled in the tube A is still 100 cm cube. So suppose if this is the volume that we have got for the gas, and it has been occupying the volume of 100 cm cube, so therefore we could write it as V is equals to 100 cm cube. So this could be written as in liter also, so that could be written as basically 0.1 dm cube, or we could write it as 0.1 liter. So this is what we have got, that is the pressure is 1 atmosphere, and again the volume is in this case has been found to be, that is 0.1 liter. So we know that when we have calculated the pressure and volume, so that is what we are verifying the Boyle's law. And suppose in this case, if we have multiplied the, or we have made the product of pressure and volume, then we will get 1 into 0.1, that is 0.1 liter atmosphere. So this was the first condition where we have maintained the pressure to be 1 atmosphere, that is when the mercury level is been found to be, that is 760 mmHg, or we could say 76 centimeter of mercury. So that has been called to be basically 1 atmosphere, and the volume that has been calculated, and it was found to be basically 0.1 liter, that is 100 cm3. So in this case, the pressure and volume, that is, it was been found to be 0.1 liter. So suppose if we have the second condition, and this is the condition 2 that I am talking about. Suppose in condition 2, what we have did is, we have, in this case, we have inserted the mercury. And if we will insert the mercury, then obviously we will know that this mercury will have that kind of pressure towards this kind of this burette, and that's the reason that this volume will get reduced. And suppose in this case, suppose if we have inserted the mercury in such a way that the height of this mercury, now it has been basically 760 centimeter of Hg is the height of this mercury level. And suppose if we have inserted basically more mercury in this, and up till the height reaches to 760 plus 30 centimeter of Hg. So in this case, what will happen? We know that the height of the mercury, it was basically 760 centimeter, and now in this case, suppose when we are talking about the pressure as P2. So now the pressure P2 will, according to the level of the mercury that we have, that would be basically 76 centimeter was earlier with us, and plus suppose if we have added 30 centimeter of mercury, so that will give us basically a total of 106 centimeter. So this will be how much pressure, the pressure of this would be how much. So that is what we have to calculate, and suppose we could calculate that also very easily, because we know that when pressure is basically 760 or when the mercury level is basically 760 mmHg, we could say it as this would be basically 1 atmosphere. So what if we have basically 106 centimeter? So therefore, if 760 or if 76 centimeter of Hg is resembling 1 atmosphere, then basically the level that we have got, the mercury level, and it is up to basically 106 centimeter of Hg, will be how much atmosphere. So that is the reason that we will do a cross multiplication over this thing, and in this case, suppose the P2 is been found to be basically 106 divided by 76, which is now after calculation, which will be found to be basically 1.395 atmosphere. So this is the value of P2 that we have got, and we have got it as 1.395 atmosphere. But if we know that if the mercury has been added in this case, then we could see that the gas that has been enclosed from the volume 0 to 100 will now be reduced. So therefore this level that we have got for mercury, this was the initial condition, and when we will insert mercury, then because of which the mercury will also try to be insert over this delivery tube and will reduce the volume of the gas. And we know that the gas is basically the gas can be compressible, because it don't have the that much strong intermolecular force of attraction, and that's the reason that could be easily reduced. We could easily reduce the volume of the gas. And suppose in that case the volume was found to be, so that would be written as V2 also. So in that case the V2 is found to be basically 71.7 cm3. So this is the thing that we are I'm trying to explain, that suppose if the mercury has been filled over here up till here, suppose like a 30 centimeter of height, if it occupies in this burette, then we could see that the volume will reduce. And this originally it was having a volume of 100 cm3, but now because of which it will reduce till that is 71.7 cm3. So this could be written in the form of liter also. So for in the form of liter, we could get 0.0717 liter. So this is the volume V2. But the pressure that we have got, so the pressure that we have got, it was found to be because by the equation that we have did in this case. So it was found to be 1.395. So therefore, when we equate this thing, that is when we make a multiplication of P2 into V2, so in this case what we'll get is, we'll get the volume, the pressure is being found to be basically 1.395. And if you multiply by the volume in liter, then it would be basically 0.0717. So if you multiply this two, again we'll get a value of basically 0.0999, or we could say that basically 0.1 liter. So this is what we get. So this is the confirmation that we have did, but we could use another, suppose if another condition is also been applied in this case, suppose we are talking about the third condition. So the first and the second condition were obeying the Boyle's law, where we could find that the product of the pressure and the volume is said to be the constant, that is it was found to be 0.1 liter atmosphere. But suppose if we have increased more in, we are talking about the third condition, suppose if in this case we have increased more value of the mercury, suppose if we have filled up till this much, so as the height of the mercury, as we could see in this calibrated burette, has reached up till basically 131 same centimeter. So therefore we are talking about the condition 3, where the pressure or the height of the mercury has been reached basically up till 131 centimeter. So this 131 centimeter it has been reached, and because of which we know that the pressure which has been known as pressure, if it is having a height of 76 centimeter of Hg, then it has been calculated to be basically 1 atmosphere. But what if we have, that is if 760 mmHg or 76 centimeter of Hg is being known as 1 atmosphere, then the height of, suppose the manometer that we have did, it is, suppose it is been calculated as 131 centimeter of Hg, then what would be the pressure? So that is what we have to calculate. So therefore the pressure in this case, it would be the third condition, so therefore we are measuring it to be P3. So in this case the P3 can be easily calculated as 131 divided by 76. So if we calculate that is 131 divided by 76, we will get basically 1.723 atmosphere. So this is the value of the pressure. So in this case basically when we are filling the mercury up till this level, and so obviously in the second condition also, if we have filled the mercury, the volume has got reduced, and suppose if we are filling more mercury, then again this volume of the gas will be reduced, and in this case suppose the volume, that is the V3, it has been found to be basically 0.058 cm, 0.058 liter. It was been found to be 0.058 liter. So if we compare these two things and we have multiplied, that is P3 into V3. So in this case what we have got, we will get basically the pressure that we have got as 1723 into 0.058. So if we multiply this thing again, we'll get an value of 0.1 liter atmosphere. So the pressure, the product, that is P2 into V2, it was again found to be 0.10 liter atmosphere, and the P1 V1 again it was found to be basically 0.10 liter atmosphere. So if we compare all these things, we could say that the P1 V1 is equals to P2 V2, and which is equals to P3 V3. So this equation has been obeying the Boyle's law, and the temperature has been set to be constant, and we know that even the gas molecule was or the number of moles of the gas was also being taken to be the constant, and hence this is how we have verified the Boyle's law. So that's the reason that we have experimentally proved that the gas obeys Boyle's law, and at constant temperature and at the same number of moles of gas. So that's it. Thank you friends for watching this video. I hope you have understood this video very clearly and you'll share this video with your friends. And yes, don't forget to subscribe to Ekeeda channel. Thank you so much.